Welcome back, children. Today we are going to learn about a new chapter. Okay, children, open your textbook at page number 41. You can see chapter number 4, heat and temperature. Yes, now do you have any idea about the difference between heat and temperature? Yes. Now we are going to learn about that in detail. Yes, children. Shall we start the topic? Yes. What do you know about heat? What is heat? Louder. Yes. Heat is a form of energy which has the ability to do work. So it's basically a form of energy and has the ability to do work. So only with the heat we are able to do our work. Clear? And then, for example, the engine moves a car by converting heat energy into mechanical energy. Isn't it? Yes. Heat can also be converted into other forms. Heat can also be not only into mechanical energy, it can also be converted into other forms of energy. For example, firecrackers, it converts into light and sound energy. Isn't it? Yes. So now about temperature. Yes, children. Now, what is temperature? What? Yes. Temperature is used to measure the degree of hot or coldness of a body. I repeat, temperature is used to measure the degree of hot or coldness of a body. Isn't it? Yes. For example, we can identify that the person has fever by placing hand on overhead. We feel the hot or cold, is it not? So we can identify the person has fever by placing hand on overhead. A device used to measure the temperature is called thermometer. Now, how do you measure the temperature? How do you measure the temperature? There is a device to measure the temperature, and the name of the device is thermometer. The name of the device is thermometer. Clear, children? Yes. Yes, children. Now, let me have a look on mind map. Okay. So, the lesson is about temperature and heat, isn't it? So about temperature, as I already mentioned, it is used to measure the degree of hotness or coldness of a body. Okay, it's a degree measure. And about heat, the energy flow from one body temperature to another is called heat energy, isn't it? Yes. Now again, there are three types of units in temperature. 3 units. So what are those? Celsius, Fahrenheit and Kelvin. So about Celsius, the melting point is 0 degrees Celsius and boiling point is 100 degrees Celsius. And Fahrenheit, the melting point is 32 degree Fahrenheit and boiling point is 212 degree Fahrenheit. And about Kelvin, the melting point is 273 Kelvin and the boiling point is 373 Kelvin. So, let me learn about that in detail. Yes, children. Now, to measure the temperature, we are using a device, thermometer, isn't it? So, there are 3 different types of thermometers. One is clinical thermometer, second is digital thermometer, and the third one, laboratory thermometer. So, about clinical thermometer, it ranges from 35 degrees Celsius to 42 degrees Celsius, right? And then about digital, it consists thermometer, okay? And then laboratory thermometer includes a range of -10 degrees Celsius to 110 degrees Celsius, right? Okay. Yes, children. Now there are 3 methods of heat transfer. They are conduction, convection and radiation. Conduction, convection and radiation. Now about conduction. Transfer of heat from one body to another is said to be as conduction. Clear? Transfer of heat from one body to another. Next, convection. Heat is transferred from bottom to top through movement of water molecules. Bottom to top through movement of water molecules. Next, about radiation. Transfer of heat energy from hot to cold body without heating the space in between them. Clear? So, we are going to learn about this in detail. Yes children, now let me have a overall look of mind map. So, temperature, we are having 3 different units of temperature, that is Celsius, Fahrenheit and Kelvin. And to measure the temperature, we are using a device said to be as thermometer. So, there are 3 different kinds of thermometer: clinical, digital and laboratory. Clear? And second part of the chapter is heat. Heat, there are 3 methods of heat transfer: conduction, convection and radiation. Clear? So, we are going to learn about this in detail. Children, you can have a look on thermometer. It works on the principle of thermal expansion, which implies that matter expands on heating and contracts on cooling. You can observe the bulb, capillary tube and the scale of the thermometer. Can you see the readings? 35, 36, 37. Scale of the thermometer is also visible. Clear? So, if you are immersing thermometer in hot water, you can observe the raise in the level of mercury in thermometer. You can observe the raise in level of mercury in thermometer. Clear children? Yes. Now children, thermometer can tell us accurately if any object is hot or cold. Why do we use thermometer? It can tell accurately whether the object is hot or cold. Clear? Next, why are they using mercury in thermometer? What is the importance of mercury there? It shows uniform rate of expansion. Uniform rate of expansion with a rise in temperature. So, according to rise in temperature, rate of expansion will also be uniform in case of mercury. Clear? Then the second point, it has high boiling point. Mercury has high boiling point. Clear? Then mercury is an opaque and shiny substance. It's an opaque and shiny substance. Hence, it is easily visible. That's why mercury is used in thermometer. Clear? Now children, there are 3 different scales of temperature, that is Celsius, Fahrenheit and Kelvin. Clear? So, let us learn about each scale in detail. So, first about Celsius scale. Celsius scale. It is the most commonly used scale to measure the temperature. This is most commonly used scale to measure the temperature. Clear? Then, it was devised by Anders Celsius. It was devised by Anders Celsius. And then, the melting point. As I said, there are 2 important points, that is melting point and boiling point. Clear? So, the melting point of pure water is 0 degree Celsius. The melting point of pure water is 0 degree Celsius. And the boiling point of pure water is 100 degree Celsius. So, it is in between 0 and 100. Okay. And then, the interval between 2 fixed points of the scale, the in between, that interval, that is divided into 100 equal parts. That is further divided into 100 equal parts, whereas each part is 1 degree Celsius. Whereas each part is 1 degree Celsius. Children, you can have a look on the Celsius scale. Here there are 2 points shown, that is boiling point and melting point. So, the boiling point of water is 100 degrees Celsius and the freezing point of water is 0 degrees Celsius. Else, melting point of the water is 0 degree Celsius. Clear? Now children, about the second unit of temperature, that is Fahrenheit. Okay, so let me learn in detail. It was devised by Gabriel Fahrenheit. It was devised by Gabriel Fahrenheit. Then, as I said, here they are having 2 points, melting point and boiling point. So the melting point of pure water is 32 degree Fahrenheit. The melting point of pure water is 32 degree Fahrenheit and the boiling point of water is 212 degree Fahrenheit. So interval between two fixed points. So the in between fixed points, the in between place, the interval between two fixed point of this scale is further divided into 180 parts. It's divided into 180 parts where each part is 1 degree Fahrenheit. Where each part is 1 degree Fahrenheit. You can have a look on the picture. So here this is the melting point and this is the boiling point. Melting point is 32 degree Fahrenheit and the boiling point of water is 212 degree Fahrenheit. Clear, children? Yes. Yes, children. Now about the third unit of temperature, that is Kelvin. Clear? Kelvin was invented by Lord Kelvin. This scale was invented by Lord Kelvin. Kelvin is also the SI unit or system unit of temperature. System unit of temperature. The melting point, here also they are having two different points, melting point and boiling point. Melting point is 273 Kelvin and boiling point is 373 Kelvin. The scale is divided into 100 equal parts. The scale is divided into 100 equal parts where each part is 1 Kelvin. Clear, children? Yes. Now children, let me learn about interconversion of units. Okay, so by using the following equation, the three temperature scales, that is Celsius, Fahrenheit and Kelvin, right? Three temperature scales can be converted from one to another. Let me learn about that. So the equation is C, that is Celsius by 100 is equal to Fahrenheit minus 32 divided by 180, that is equal to Kelvin minus 273 divided by 100. Clear? So now to find the Celsius, the formula is, with the Fahrenheit to find the Celsius, the formula is 5 by 9 into F, that is Fahrenheit minus 32. Clear? And to find the Fahrenheit from the Celsius, the formula is 9 Celsius divided by 5 plus 32. Clear? So let me apply the formula. For example, children, to convert 59 degree Fahrenheit to Celsius, to convert 59 degree Fahrenheit to Celsius. So now we are going to convert Fahrenheit to Celsius. So how to do? Formula is C is equal to 5 by 9 into Fahrenheit minus 32. Isn't it? Yes. Now we are substituting instead of Fahrenheit the respective value 59. So 5 by 9, 59 minus 32. Clear? So the value of the subtraction is 27. 27. So 5 by 9 into 27. So 3 9s are 27. So 5 into 3 is 15 degree Celsius. Clear? So 59 degree Fahrenheit is 15 degree Celsius. Clear, children? Yes. Now children, let me learn about another example. Okay. So the temperature of the healthy human being is 37 degree Celsius. Express this temperature in Fahrenheit. So we are having a Celsius value. Now we are going to convert into Fahrenheit value. Clear? So how to do? What is the formula? As I said, Fahrenheit is equal to 9 into C by 5 plus 32. C is the Celsius value. Okay. So you are having 37. So 9 into 37 by 5 plus 32. Clear? So now 5, you are just dividing 37 by 5. So it is 7.4. Isn't it? 7 5s are 35. Then 2 remaining. Then 20. That is 4 5s are 20. But still it is 7.4. Clear? So 9 into 7.4 plus 32. That is 66.6 plus 32. And the final value is 98.6 degree Fahrenheit. So finally 37 degrees Celsius is equal to 98.6 degree Fahrenheit. Clear, children? Yes. So thus, children, as of now we have learned about temperature is used to measure the degree of hot or coldness of a body. Clear? And then thermometer is a device which is used to measure the temperature. Thermometer is a device which is used to measure the temperature. Then there are 3 units of temperature, that is Celsius, Fahrenheit and Kelvin. Clear, children? Yes. Now we are going to learn about thermometers and different types of thermometers. Now children, you can have a look on clinical thermometer picture. Can you see? Yes. See, it will be a long narrow glass tube. You can see a long narrow glass tube, and one end is sealed, one end of the tube is sealed, and the other end you can observe a glass bulb. You can see a glass bulb here which is filled with mercury. Glass bulb which is filled with mercury. Clear? Yes. And then you can see a kink here, a round circular construction kink. Okay. So this kink will be useful to prevent the immediate backflow of mercury from the tube to the bulb. To prevent the immediate backflow of mercury from the tube to the bulb. Clear? So this is what about the picture. Yes, children. Now about the clinical thermometer. Clear? So it is used to measure the temperature in human body. It is used to measure the temperature in human body, and it ranges from 35 to 42. You can observe in the picture the range is from 35 to 42. Clear? And then, as I said, it has a long narrow glass tube. It has a long narrow glass tube, and one end is sealed, and in the other end it is filled with mercury. A glass bulb is seen there which is filled with mercury. Clear? Then the normal body temperature of human is 37 degrees Celsius or 98 degree Fahrenheit. Then it never goes above 42 or below 35 in Celsius scale, because the range is in between 35 to 42. It's according to human body. Then the clinical thermometer has a kink. Here a circular transparent construction will be there which is above to the mercury bulb. Okay, then that is said to be as kink, K-I-N-K. It has a kink which above the mercury bulb, and this kink prevents immediate backflow of mercury from the tube to the bulb. It prevents immediate backflow of mercury from the tube to the bulb. So when you are checking with this thermometer, this mercury flow will raise up and will be again it will be turned to its original position, right? So that is because of this kink. Only in case if the kink is there, that will help to prevent the immediate backflow of mercury from the tube to the bulb. Clear, children? So this is what about clinical thermometer. Yes, children. Now you can see the digital thermometer. Digital thermometer. Clear? So this digital thermometer does not contain mercury. It does not contain mercury. It has a plastic body. It has a plastic body which is easy to use. So if you are using this, you can see the result in a digital manner here. Okay, you will be getting the results in digital manner. So this is what about digital thermometer. Yes, children. Now about the second type of thermometer, that is digital thermometer. Mercury is toxic in nature. It's a known fact. This digital thermometer does not contain mercury. It does not contain mercury. It has a plastic body which is easy to use. It has a plastic body. Then it consists of thermometer, which is used to sense the temperature. The temperature. And another small device is used here. That will measure the current passing through the passing through thermistor and sends the information to LCD. Sends the information to LCD where the temperature is displayed in numerical values. Can you understand? I repeat once again. Here they are having thermistor which is used to sense the temperature. So this part is useful to sense the temperature. Then one more small device they are using here that will measure the current passing through thermistor and sends the information to LCD where the temperature is displayed in a numerical value. Can you see here 36.4. So the numerical display will be given out here in this type of thermometer, that is digital thermometer. Clear? Yes children, now about the third type, that is laboratory thermometer. Laboratory thermometer. They are used in laboratories to measure the temperature. They are used in laboratories. Then it can measure the temperature of hot objects such as boiling water or cold objects such as ice. Then it commonly includes the ranges from -10 degrees Celsius to 110 degrees Celsius. So the range is in between -10 to 110 degrees Celsius. It is used in various fields. It is used in various fields such as pharmaceutical, environmental, food and petroleum testing. Clear? So this is a picture of laboratory thermometer. Clear? Now children, about the second part, heat. Clear? So about heat, as you all know, heat is a form of energy. Heat is a form of energy. And then when there is a difference in temperature, between the two bodies, okay, then the energy flows from one body to another, that is termed as heat energy. The energy flows from one body to another, whereas the temperature between the two bodies should be different. Okay, so that flow of energy from one body to another is termed as heat energy. Clear? Then heat flows from the body at high temperature. It flows from the body at high temperature to the body at low temperature. So it flows from high to low temperature. Clear? Yes children, always the heat flows continues till both the bodies reach the same temperature. It will continue till both the body reach the same temperature. This temperature is known as equilibrium temperature. It's known as equilibrium temperature. For example, the natural source of heat energy is sun, isn't it? So sun is an example for heat energy, how it's getting transferred from one body to another, from higher temperature to low temperature, how it has moved. So for that best example is the natural source of heat energy, sun. Clear? Yes children, now about unit of heat. Okay, so what is the unit of heat? It's commonly used units to measure the heat or joule and calories. Unit of heat is joule and calories. So in short, it's said to be as J and CAL. Okay, so what do you mean by 1 calorie? 1 calorie is the amount of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. I repeat, 1 calorie is the amount of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. Clear? So the relation between the units, that is calorie and joule, is 1 calorie is equal to 4.2 joules. 1 calorie is equal to 4.2 joules. So, or else 1 joule is equal to 1 divided by 4.2 calories. 1 divided by 4.2 calories. So 1 kilocalorie is equal to 1000 calories. 1 kilocalorie is equal to 1000 calories. Is that clear? Yes. Children, now you can see this activity. There are 3 beakers, A, B and C. A with cold water, it's filled with cold water. B with water at room temperature, and C, it's filled with water, that is hot water. So C with hot water and A with cold water. Okay, so now I am going to dip my left hand in hot water. This is hot. Okay, then my right hand with cold water. I am going to dip my right hand in cold water. Then I'll allow it for 30 seconds. Okay, now I'll dip my both the hand simultaneously in the beaker containing tap water, that is at room temperature. So now I feel that the hand dipped in hot water felt the water at room temperature as cold. Okay, the hand dipped in hot water felt that water at room temperature is cold. Clear? Now this hand, that is the hand dipped in cold water, felt that water at room temperature is hot. Clear, children? Yes. This clearly explains the relationship between heat and temperature. Now children, for you all an activity. Okay, so now take two soft drink cans, just name it as C1 and C2, and then paint the outer side of the can C1 with black color and C2 with white color. C1 with black and C2 with white color. Clear? Then half fill both the cans with cold water and leave. Okay, and then you want to place it in sun for some time. Then you check the temperature with the help of a thermometer. Okay, and then now place, after some time, after you have checked, then place the cans in cool shady place. In cool shady place. Then again check the temperature of both the cans with the help of a thermometer. So you will be getting two readings. One after keeping in sun, and then again after placing them in cool and shady place, you are getting another temperature. So it's two set of readings we will be having. Isn't it? Do the activity and observe the results. In general, you will be getting the temperature, that is C1 will be more than C2 in the first case. That is when you are keeping under sun, no, C1 will be having more temperature than C2. And in the second case, C1 will be having less temperature than C2. So this activity clearly shows that black body absorbs heat fast and radiates heat fast. Clear? I repeat, black body absorbs heat fast and radiates heat fast. So do and show the activity. Just submit the result in your class email ID. Clear, children? Yes, children. Now let's have a look on the video that clearly demonstrates about the general effects of heat in solid, liquid and gases.
We have already seen that adding heat to a matter causes its atoms to vibrate more and more. As these atoms vibrate, distance between these atoms increases. As a result, size or volume of matter increases. Most of solid, liquid, and gas expand on addition of heat and shrink when heat is removed from it. Solids expand less compared to liquid and liquids expand less compared to gas. Let's see few phenomenon where expansion or shrinkage takes place due to heat. Expansion and shrinkage in solid. You must have seen rail lines. Rail lines is made of iron rails. If you observe closely, you will see some space between two consecutive rails. This space becomes helpful during summer. Due to heat, rails expand and this space get occupied. In winter, rails again shrink back. If space is not left there, rails will bend and cause derailment of trains. If you put very hot or cold water in a glass jar, sometimes it breaks. Jar breaks because inside of jar expands or shrinks due to high or low temperature, but outside of the jar remains same. You must have seen the electric wire hanging between two poles. During summer, these wires expand due to heat and becomes loose, but during winter these wires shrink back and become tight. Expansion or shrinkage in liquid. Liquid also expand on heating. We measure liquid by its volume. On heating, volume of liquid increases, whereas on cooling, its volume decreases. Liquid expand on an average 10 times more than solid. Expansion or shrinkage in gas. Gases expand most on heating. When gas is heated, all the heat energy get converted to kinetic energy of gas particles and thus increases the speed of gas particles. Due to high speed, density of gas particles at a place decreases. This is also understood as gas becomes lighter when it is heated. In coastal areas such as Chennai, Mumbai, Kolkata, etc., during day, cold breeze flows from sea to land, whereas during night, it flows from land to sea. Before finding the reason behind this, let's recall two things. 1. If a thing takes more time to heat, it will take more time to cool. For example, if a steel plate and a plastic plate are kept in sunlight and steel plate becomes hot sooner than plastic plate, if both are kept in shadow, steel plate will become cold sooner compared to plastic plate. 2. Land is like steel plate and water is like plastic plate. Land heats and cools faster compared to water. During daytime, land gets heated fast and thus the air around it also get heated. As air becomes hot, it becomes less dense and leaves space to be filled by colder air. Since air around seawater remains cooler, it moves towards land and fills the space left by hot air on land. Thus air or breeze flows from sea to land. During night time, land cools fast and air near the land becomes dense, whereas water cools slowly and air around water remains hot and less dense. Space between this hot air is filled by cool air from land and thus breeze flows from land to water.
Yes children, now moving further about different methods of heat transfer. So in general there are three methods of heat transfer, that is conduction, convection and radiation. Clear? So you can see this picture here, flame is there, a container is kept over the flame, okay, with a handle, a container with handle, and within the container water molecules are there. Water molecules get heated, so it's moving towards up, it's moving towards up. So the molecules which are upside is moving towards down. Okay, so the molecules which get heated is moving towards up. The thing which remain upside moves down. Clear? Then, so here you can see all the three methods together, that is conduction, convection and radiation. Okay, so once again I'll explain about conduction. Conduction, energy is transferred by direct contact. Energy is transferred by direct contact. The heat which is observed in the water molecules will be passed to the handle, will be transferred to the handle also. If you touch the handle, you can observe the heat. Okay, so this is what about conduction. The next mechanism, convection. Convection, energy is transferred by mass motion of molecules. The water molecules get heated and it is moving towards up, and the molecules which are present upside will move towards down. Okay, so it's the movement of molecules is meant to be here as convection. Clear children? Yes. Next about the third thing, radiation. Here energy is transferred by means of electromagnetic radiation. By means of electromagnetic radiation. You can see the flame here. From the flame, the heat energy is getting transferred in all directions upside, in all direction here, and that is what meant to be here as radiation. Can you understand? So all the three mechanisms are shown here in the same picture. Now children, let me learn about these three methods by watching the video.
If you stir a boiling liquid with a plastic ladle, after a few moments, the ladle will become quite warm. The same will happen with a wooden ladle. And a ladle made of metal can even become too hot to handle. This is because the heat from the boiling liquid is able to travel up the length of the three ladles, quite slowly through plastic and wood, and very fast through metal. But how does heat manage to do this? How does heat travel through things? Well, when the hot liquid heats up the end of each ladle, its molecules, or in the case of metal, its individual atoms, start to vibrate more rapidly. And when the heated molecules, or heated atoms, vibrate faster, they start bumping faster and faster into their slower neighbors, causing them to speed up in turn, and bump into their neighbors, and so on all along the ladle. In this way, the increased speed of vibration, and therefore the heat, is passed on from molecule to molecule, or from atom to atom. Heat is conducted by a sort of domino effect from molecule to molecule, or from atom to atom, along the hot object and into your fingers. That's one kind of heat transfer. Convection. The hot object causes the molecules of air above it to speed up. The hot air expands and becomes less dense, and is therefore conveyed upwards. That's a second kind of heat transfer. You look nice and warm. Where does the heat for that hot water radiator come from? The furnace, of course. Is the furnace always kept in the basement? Why couldn't it be in the attic for a change? What would happen if it were? Anyone on a floor below would freeze. That's what would happen. Why is this? The furnace heats the water in a tank. The hot water rises up through these pipes and into the radiators, where it cools, and then the cold water flows down through these pipes and back into the tank, where it is heated up again, and so on. But why does hot water go up and cold water go down? Because of the principle of buoyancy. If you hold something that is less dense than water, such as a cork, in the middle of a beaker of water, the buoyant force pushing that cork up will be greater than the force of gravity pulling it down. And as soon as you take your hand away, the cork will rise to the surface. Now, when water is heated, its molecules speed up and it expands and becomes less dense. And this less dense water will therefore go up, and then cool and become dense again, and therefore go down. And that's exactly how hot water heating systems work, and why your furnace is in the basement. The principle of buoyancy applies as much to gases as it does to liquids. When air is heated, its molecules speed up, and it expands, and becomes less dense. And so hot air rises, just as hot water rises. Hot air goes up, it cools, and the cold air goes down. Since the behavior of gases and liquids is so similar in this and many other respects, but how can the sun transfer heat to you? You're not touching it, so there can't be any conduction, can there? And since most of the space between you and the sun is just that, space, except for the thin layer of air formed by the Earth's atmosphere, there can't be any convection either, can there? Because once you get beyond our atmosphere, there's almost nothing out there to do the convecting. But the sun still feels hot. Amazing. How is that possible? Is there a third kind of heat transfer which allows heat to move through empty space? Yes, there is. And to understand it, you must first of all remember that heat is a form of energy. Now, energy can travel in various ways, but one of the chief ways in which heat energy travels is in the form of waves. By means of waves, energy can move through any distance. You can do it yourself. You can make that umbrella move without touching it. Tie one end of your rope to the umbrella, and now move your end of the rope up and down. You can actually see that your energy is traveling through the space between you and the umbrella, and then making the umbrella move. The heat energy from the sun travels like that. The sun sends out waves of heat energy in all directions. Each of them is rather like the spoke of a wheel, and this is exactly what scientists call them, only they use the Latin word for spoke, which is radius, from which they get the word radiation, the name given to this third kind of heat transfer. So it's by means of radiation waves that the sun can transfer its heat energy to you. and make your molecules go faster and therefore make you hotter. Even though the sun is millions of miles away. Just as, by means of waves again, you can transfer your energy to the umbrella and make it move, even though you're standing several meters away from it.
Now children, you can see the picture of Thermos Flask. You can see that. Okay, so what is Thermos Flask? It generally maintains the temperature of the substance. It is hot substance as hot and cold substance as cold, isn't it? Yes. Now about the structure, they are having a cap, they are having a stopper, they are having a double wall vessel. Double wall vessel is very important here to minimize the effect of conduction, convection and all. And then you can see here a vacuum is created. Okay, it's observed here. Then down we can see a silvered wall, it is polished wall, so that the radiation effect will also get minimized. And you can see an outer case. So this is what about the picture of Thermos Flask. Yes children, now about the last part of the chapter, that is Thermos Flask. So about this, as I said already, it maintains the temperature of substance present in it. Mean to say, hot things will be hot and cold things will remain cold, isn't it? Yes. Now, it's achieved by minimizing the exchange of heat by conduction, convection and radiation. So, it's minimizing the exchange of heat. Here, it's minimizing the exchange of heat by conduction, convection and radiation, which are the three methods of heat transfer. Okay, then it consists of double wall container. This Thermos Flask contain double wall container, and then a vacuum is created in the gap between the glass walls. So here you can see which is there in between the glass walls, in between the glass walls. So the purpose is to minimize the conduction, and it reduces the heat loss. Clear? Then both the walls are polished, shiny, a silvered wall. It's polished and shiny. Okay, shiny and silvered wall, so that the heat radiations are reflected. So the third method of heat transfer, radiation, that is reflected here. Okay, and then the outer case will be made of an insulating material, that is plastic. Clear? So this is what about the Thermos Flask. So children, this is how in Thermos Flask hot things are hot and cold things are cold for long time. Clear? And children, that's all about the unit. After watching the video, read the chapter in textbook and then start doing the exercises. That's all. Thank you children.